Okay, so now we are gonna go to solving multi-step equations. You know, previously, you guys went over how to solve like one-step equations. Or if you're adding or subtracting to move something over, or multiplying and dividing to move something over. But today you may have to do more than one thing. If you look at example 8, remember equations sometimes have an expression equaling like another expression or a number. That's where we're getting to now. And we want it to be like a letter equaling a number. At least an equal sign between those two things, right? Well, over here on the left, we have our term that has the letter. We're trying to solve for that. We're trying to get that all by itself. So that means we want to move this over first. We do that by doing what? Subtracting. Good. So we're going to subtract 3 from both sides. So we have 8W equals 7. And then, so that second step, if you have 8 right beside the W, that means multiplication. What's the opposite operation of multiplication? Divide, right? So we're going to divide both sides by 8. And we are going to leave that as an ugly fraction. We're not really working with decimals very often. I don't want to say we never are, because we are. But for the most part, we're going to be working with fractions. If that could reduce, you would do that, but it doesn't. In WebAssign, when you type this in, you could use the / or sometimes it will open up a toolbar and you'll pick like a fraction tool, but not always. And it's because they know you can use that / in WebAssign. So if you don't get a toolbar pop up to choose, you get a fraction, you don't have to automatically think you're wrong. It's just sometimes they know you can use that / on your keyboard. Okay, number 9. What do we do first? Right, we want to take this and put it over here because this is the term that has the W, has an ugly fraction in front of it, or it's actually a Y, not a W. We have 5/6Y equals 10. So remember, this is a little different than that. In that, we have a fraction by a letter, not a whole number. So we flip and multiply, right? Good. You have a fraction, you multiply times the reciprocal, or they flip and multiply. We do that because see how your 6's cancel, your 5's cancel, leaving you with 1Y, basically. When you multiply times the reciprocal, that makes that a 1 every time. If you need to, you can put 10 over 1. So you can see your cross reducing. These are the numerators, those are the denominators. And just reviewing cross reducing. Both of those things that I circled can be divided by 5, right? So 5 goes into 5 one time, 5 goes into 10 2 times. So we cross it out. That's what cross reducing means. You're crossing it out, you're changing it. So 2 times 6 is 12. And I don't have to put that back over 1. Sometimes I accidentally skip over that. But do you see in the bottom, 1 times 1 is just 1? We don't write it like that as an understood thing in math. Well, now we may have variables on both sides. Might get just a little bit busier, kind of working our way up to more complex equations. So let's look here. So sometimes you might need to do some other things before you start to solve. So if you look at this example 10, kind of ignoring the right-hand side for just a minute, think of that just like simplifying an expression. Do you see anything that's a like term? Right, so we want to combine that before we move it. When we're combining it, we do exactly what it says, basically. So you see 6, and there's a negative or minus 11. So I like to write 5Y first, and then do that, but you could have written negative 5 first, because 6 minus 11 is negative 5. And then on the right-hand side, those aren't like terms over there. We can't simplify that anymore, so we don't. Sometimes you're going to hear me call that cleaning it up, right? Like think about when you have laundry all over your dorm room or your room at home, and you're cleaning it up, you're putting all the colors in their white pile, right? All your whites, and maybe all your jeans. Depending on how picky you are about your laundry, how you separate it. That's what we're doing with these terms. We want to clean that up before we start moving stuff around. So you could technically start in 4 different spots in this one. There's variables on both sides and constants. I like to keep variables on the left when I can. It doesn't always work out, but when I can, I like to do that. So I'm going to take this entire term 2y. I'm not dividing 2 away from y. And you want to take the whole thing and move it. Since it's a positive 2y, I subtract 2y. I take that entire term just like it, if it were just a number, stuck with it. And so when I take 5 minus 2, that makes that now a 3y. Let's go ahead and bring down -5 and our equal sign. This zeroed out. One thing to be careful of, over here it was like saying 2y minus 7. Well, now that is a -7, right? So it's not always just an operation. Sometimes that sticks with it. That's its sign if it's negative. So now we're going to take this -5 and move it over here with its like term. So since it's negative, since it's a minus, we add +5. So that will zero out. So I have 3y equals a -2. What's my last step now? Divide. So hopefully you guys kind of remember some of this stuff. They're hoping when you come into pre-stem that you can solve some basic equations. That's not always the case, and that's okay. That just means you need to start practicing them. Remember, the best way to learn this material is to do the same problems we've done together. Do it by yourself and see if you did it right. Check those steps. That's what each line of this you can see if you are understanding each step. Are there any like terms in number 11 to clean up on the left-hand side? There's not on the left. There's just a constant and then the term that has x. And then on the right, same thing. But we can start moving stuff around, can't we? You can start by subtracting 8, subtracting 2x, or subtracting 10, or adding 4x, right? Yeah. I just try to do it always the same way, just for instruction, and move my variable first, but you can start by subtracting 8 first. Totally fine. You're gonna get the same deal. Amen. So, but this, if I'm gonna move it first, since I'm the teacher, I get to give it to you. I'm gonna add 4x. And sometimes I will just do it the way you want it, but since I'm first instructing, I just do the same thing. Some people don't like choice. Believe it or not, they're like, there's 4 choices, which one's best? They're all best. So I just try to do it the same way. So we have 6x equals 10. Now I'm going to subtract 8 second, where you might have done it first. So what that means is if you would have subtracted it first, you would have probably added 4x second, which is we flip flop, we get the same deal, right? Do you see that? So 6x equals 2. Then we get to divide by 6. Can you reduce that? Yeah, so 1/3. Both of those numbers can be divided by 2. You do not want to answer out of the decimal, especially in that case, because 1/3 is a never-ending decimal. If you ever struggle with simplifying fractions, like let's say that was a really big number and you didn't really think that hard, your calculator will, if you have a TI-30XS, your calculator will simplify them for you. You just choose the fraction button, that N/D, and you can type it in 2/6, and if you click enter, it will just reduce it for you. Super handy, and your this calculator does go between decimal and fraction form. Do you remember all that, guys? Yes, good. That means we're in a good spot. I love it. So now we're going to start with, well, what if we have equations that have parentheses? So your first goal would be to get rid of them. You guys remember the word distributive property. That's what we're gonna do. We're gonna distribute. We're going to take -3. I do use little arrows to help it helps keep me organized. But -3 times 2x is a -6x. And then don't forget to distribute to the 1. So -3 times 1 is -3. Equals 7 times 2 is 14. And 7 times a -x, we write negative or -7x. Everybody remember that? But hopefully it's starting off fairly easy for you that you remember. Okay, so we have variables on both sides and constants on both sides. You can start anywhere you want. I'm teaching, so I get to choose. I always keep my variables to the left. The reason I do, we start learning inequalities, it makes most sense to read them with the variable on the left. But sometimes even with inequalities, we keep them on the right and have to fix it at the end. So it really doesn't matter. I'm gonna add 7x over. So -6 plus 7 is a 1x. Do I have to put a 1 there? No. If you'd like to see it, there are times it's helpful. You can put it there. I'm gonna put it in red. Just know that that's understood. And I'll still bring down -3 equals 14, the stuff we haven't changed. Then if we're trying to get x by itself, what do we move? The 3, and we're gonna do that by adding or subtracting. I'm gonna say +3, adding. So I have x equals 17. Down in the did your notes print like that?
Yeah.
14?
Yeah.
Okay. Well, we'll just fix that. I'll just see if I can find what it was supposed to say.
And 13 is kind of weird.
Yeah, 13 has.
Yeah.
Yep. Sure enough. Hold on. Just let me pause on this. Okay, we fixed our little typos that were in our printed notes. I'm just gonna squiggle it out. Okay, so we have a parentheses in this problem, but do you see how we have a 10x minus 3 in front, then a parentheses? Never, ever, ever do anything outside of the parentheses first. What I mean by that is sometimes it will be just a 10 minus 3. I can't combine that anyways, right? And I'm just saying that because, like, looking at example 15, that's a really common mistake that happens in problems with parentheses. But your eyes should always be drawn to here first, no matter what, no matter if these were like terms or not. So let's rewrite 10x. And then we're going to start distributing -3 times 2x is a -6x. -3 times 5 is a -15 equals 13. So do we have anything we can clean up here on this side, on the left side? Yeah. So x's become 4x. And then rewrite -15 equals 13. So now we'll start moving things around. This is the term with the letters, so we need to put the 15 over on the other side. So we're going to add 15. 4x equals 28. Is x by itself? Not yet. The term that has x is, but x has a 4 in front of it, so our last step is to just divide. So while I'm lecturing, you guys are welcome. If you think I'm going slower than you can work it out. Go through the steps. If you're unsure, pause. I love that because that means that you remember this and you're getting the practice and you're just affirming that you know how to do it. If you're watching a lecture video, Pause it if you want, try it. Bump it back, watch it again, try it again. Okay, let's go up to example 14. Remember we had to fix our little printer issue that I had there. So we have a parentheses in this problem, but do you notice we have a minus sign in front of it? Yes. So even though it's not a number, it is a minus sign that's directly in front of it. So we have to distribute that minus sign. We're doing nothing with the 6. It's just in front of it. So we rewrite the 6, but we are taking that negative and distributing. It's going to change these signs to the opposite. A negative times a positive would make that a -4. A negative times a negative would make that a positive 7x. See how those signs became just the opposite of what they were when they were inside the parentheses. Now we have some like terms there on the left that we need to clean up before we move anything around. We have 6 minus 4. So that's 2. This is when we can start moving stuff. There's not like terms on the left or the right now. We have variables and constants on both sides. So I'm just in the habit of saying, okay, I'm going to take this variable and move it to the left. It's a positive 3x, so we would subtract 3x. I'm going to go ahead and bring down 2. 7 minus 3 is a positive 4x equals this zeroed out. So we're left with a 2 over here. Now we need to move this 2 to this side by subtracting. You see how it zeroes out over there on the right hand side? And that's okay. Don't stop there and think there's no solution. Go ahead and finish out the steps, because if we were to divide, can't we say 0 divided by 4 is 0? So that just means our x value was a 0. We can get x equals 0. Like what sign I'll put up there, if there's no solution, right? No solution. Well, there's not going to be that. Okay. The way that there would ever be no solution is if your variable is zeroed out. Because what we can't do is we can't say 0x equals a number and try to divide by 0. That's undefined, right? Oops. So you can't, that's something you can't do. That's very different. I want you to get number 15 and try. I'm gonna pause the video for a minute. Notice I squared this out. This is that case where I see a lot of common mistakes, even in algebra, like algebra percent. We do problems just like this, and I talk about it with them. It's really tempting to want to take 5 plus 4, then distribute. But think about order of operations. You're supposed to work parentheses first. And most of the time that meant inside the parentheses, but it also means distribute too, okay? So if you ever have a parentheses, we want to get rid of that first before we ever do any operation. So don't be tempted to do anything other than distribute first when you see parentheses. So we're just going to rewrite our 5, and now we're going to distribute 4 times y is a positive 4y, and 4 times a negative 3 is a negative 12. If you did put a 9, just scribble it out and start over and follow along from here. And just know that you make yourself a note, don't do that again. So over here on the right-hand side, we have like terms. So since there's nothing alike on the left, I'm going to rewrite it before I start doing the simplifying. And 5 minus 12 is a negative 7. And then I just rewrote my plus 4y. Could you have written 4y minus 7? Yes. And I might have done that. I do it both ways when I teach this. It's just different every day. So now we have letters and numbers on both sides. So let's start moving stuff around. You can start where you want it. I'm choosing to move my 4y first. I'm going to do that by subtracting. my four y, so 5 minus 4 is 1. Remember, we don't have to put those understood ones. And then bring down minus 4 equals negative 7. Then we're gonna start moving those constants to the other side. We have a minus 4 that needs to go over here, so we would add 4. So y equals a negative 3. So remember when we first learned solving equations, that you should be able to plug this into your y's and simplify both of them, and they should equal each other. I don't make you go back and check it. WebAssign sometimes says solve and check, but I will have no idea that you checked it. I think it's good practice, especially if you're struggling with solving equations. Okay, moving on to topic 2.3. This will be the next assignment that you'll be working on. So remember 2.1 and 2.2 go together. And then 2.3 is all by itself. Actually, let me take that back. I added some 2.2 in it so you get extra practice in solving equations. So you have example 1 or assignment 1 is 2.1 and 2.2. Assignment 2 is a little more of 2.2 and some 2.3, because there's only so much you can do with what we're learning today. Okay, so we're going to be translating a sentence into an equation and then solving. And you just need to remember some terminology and what that means. And you also need to know that order kind of matters in a couple instances, especially with your signs. Really makes a big difference. Adding isn't as big of a deal as subtracting. But anytime, let's put a star by, we say added to and more than. If we say 6 is added to y, that means y came first. Okay, it's like you already had y. Let's add it to it. So you would write it like y plus 6. It's kind of backwards. You don't really write it exactly the way you read it. Same with the word more than. 8 more than x. It's kind of like you already had x. If x was $5, now you have 8 more. They're saying you had x. Now let's add 8 to it. The rest of those with the sum verbiage is written just like that. So order does also matter in WebAssign with adding, but I understand that when you're adding those things together, it's really not going to change a lot, even if you have a negative in there. But it does matter when you say minus, you have some negatives. But this, if we say the sum of x and y, you just put the plus sign where you read and. T increased by 9, T plus 9, the total of 5 ny, so 5 plus 5. So those are really read and written into their math sentence from left to right. The exception are the 2 I starred. Those are backwards of it. And if you don't have your notes printed right now, I wouldn't stress about writing all this down. I have completed notes up there. You can print this and feel a little less stressed. But don't forget to print them before next class period. Some course materials and assignments underneath unit 1. And don't forget to bring them after you print them. All right, minus. So let's go to the 2 that are kind of in weird orders. If we say less than, just like more than. And if we say subtract from, those are the 2 that you need to be careful of when you're writing those 2 down. So if we just say minus, we can just replace it with that minus sign when we write it in our math sentence. But if we say 7 less than t, we would run a write 7 minus, or I said 7, row t. We would want to write t minus 7. M decreased by 3. So m minus 3. Word difference, we know that indicates subtraction. So the difference between y and 4, so y minus 4. But when we say subtract 9 from z, that meant z came first. So we're going to say z minus 9. things that indicate multiplication when you're reading it is like the word twice. That's not an exponent, it would just be like saying 2 times a number. We say twice. I already jumped down there, didn't I? If we say twice W, that means you have 2 of them, so you would just write 2W. Up here, they just use the word times, 10 times T. Because it's algebra, we don't really want to use an X to indicate multiplication anymore. And especially since that's a letter and a number right beside each other, we can just write them right by each other to make it easier. If we say the word this is a really big one that really need to focus on sometimes. We say of, that means multiply. If I say 1/2 of, that means you have a fraction of X. I can just put an X beside it. Product indicates multiplication, so they may say, what's the product of Y and Z? You could just write Y and Z right by each other. And sometimes they just say multiplied by 11. So you could write Y times 11. An easier way, and it's not changing the order of operation, would just kind of flip it around and just write 11Y. That's how you're going to see it in algebra. You're never going to see Y in front of the 11 right by each other. Just don't do that. Division, you could write as a fraction or with a division symbol. I always write as a fraction because a lot of the times you have another operation and it's just easier to work with like that. Notice when we were working with equations, we never saw divided by symbol in there. So that's kind of why. But X divided by 12, that's really the best way to just write it instead of with a division symbol. The quotient of Y and Z, so it's like whatever's read first is on top. My Z, I always put a little line through it so it doesn't look like my 2's. Sometimes I do a little loopy with my 2's, and sometimes I don't really know why it's different. I'm sure what happens with my hands. The ratio is division, and it is read top to bottom as well. T over 9, so small. T over 9. Or if you want to write it with a slash, that's okay. I mean, easier in that space, isn't it? And then finally, you may see some exponent words. And they just either say square, which means 2 is the exponent, or the power of 3. So you put 3 as the exponent. Or this one says cube. Remember, cubes are 3's as well. So the square of X, we would write X squared, X with a little exponent. And if it said the cube of A, it would be like saying A to the 3rd power. So cube means 3, square means 2. Some of my spacing got kind of weird too on my printout. My example 16 is right here. It tells you the instructions, says translate and solve. Is yours? Is it there? Okay. Well, eventually I'll fix that a little bit. So that first line is on the right page. Hopefully, people that watch this lecture and video in the future, it looks nice and neat for them. Okay, so we're gonna practice setting these up. I'm not gonna solve them now. I'll let you solve them. I'll push pause on this video and you can check yourself, okay? It'll be a good time to practice solving equations, and it won't take very long because these are pretty short equations. So if it says 5 less than a number is 13, and that's one thing I didn't talk about. So these are going to be equations, and anytime you see the word is, I'm not really sure why I wrote is with it. Anytime you see the word is, that's going to be your equal sign. So what I like to do is circle it so I can see the 2 sides of my equation right off the bat. If it says 5 less than a number, anytime they say number in WebAssign, they're going to say, I feel like the terminology is, it'll say the number X. So it's telling you, you have to use X. Because X is what we don't know. So, I don't use that in this, I didn't write it like that, but it'll say less than a number X, so X is your variable. If we say 5 less than a number, the number is the unknown, so I'm gonna go ahead and put the X above it. Remember that less than was one of those, things where it's a little bit backwards from what you read it. So we're gonna write X minus 5. That was one of those terminologies that I starred. And then we have is 13. In WebAssign, you're gonna have to type all of that in a box. And then you're gonna have X equals what? So you'll solve it and you'll put your solution there, which we'll do at the end of all this. I know you can probably solve that real quickly. B, the product of 5 and a number is negative 15. So I'm gonna go circle the word is, because I know that's where my equal sign is gonna be. And if I say the product of, what does that mean we're doing? Multiplying, and it's just, and a number. We know a number is X. We're gonna say 5X. A lot of words to just write down 2 things. Is your equal sign and a negative 15. So you will have to type all of that out in a box in WebAssign and then solve. The sum of 8 and a number is 3. Let's circle is again. Put our equal sign. We're saying the sum of 8 and a number. What operation's happening with those things? Addition. So it's just going to be here. Remember, this is the letter X. So 8 plus X equals 3. Super easy so far, wouldn't you say? That hasn't been too hard. We did throw it doesn't really write, you know, left to right on one of those less thans. Sometimes you're going to have some parentheses in there. D isn't the answer yet, or isn't one of those yet. But we are building up to do a little more in D. The difference between 3 and twice a number is 2. Sounds a little bit busier because we see a twice a number. But it's saying the difference between 3 and whatever twice a number is, right? See how I kind of sketch it above? It kind of helps me pull it apart. So I have 3 minus 2 of those X's. Remember, number means the letter X. Equal sign 2. So letter E is a really good example of something to look for to help you know if you have to use a parentheses or not. Notice in letter E it says 3 times the sum. Do you see 2 operations almost said back to back? If you see something that says 3 times and you see like something like the sum or the difference, you know there's probably going to be a parentheses. That's a good indication with the words. They don't tell you it, but so you're going to think that's where my parentheses is going to start. Obviously it would end before the word is. So how many of you did dissecting sentences in English? I think we all did. Personally, I hated it. I'm not an English person. I teach now. I hated that part. I like writing papers, didn't like all that other stuff. We're sort of doing that with math. We're just kind of like trying to set apart how we're going to write it as a math sentence. We have 3 times the sum of twice a number and 5. How are we going to write this inside the parentheses? Very good. 2x plus 5. So where we see the word and, that's where we do our sum. We know twice a number would be ready 2x. And then we're going to write equals 3. So sometimes the ones that require parentheses are harder to pick up on, but hopefully I've helped you key in on what to look for. And then letter F says 2/3 of a number is 30. So what does 30 mean you're gonna, or mean you're gonna do? Multiply, right? And if we do 2/3, we're just gonna write it as a fraction. 2/3 of a number, so 2/3 x equals 30. So go ahead and take just a minute to solve those. I'm gonna pause the recording. Please pause the video for those of you in front of me. Hopefully you were trying to solve this on your own. You may not be done. I know I did it very quickly. Class is almost over, so I just want to talk a minute while you're finishing. Super important to practice those things. Don't always feel like I have to be there to guide you through. I would venture out to say, if you're not comfortable practicing that right now, or if you're not gonna attempt it, we need to probably talk. Okay? Because you have to push through at some point, which I think all of you are in front of me. I'm just saying that for everybody's benefit, because remember, you're in algebra for STEM for a reason, right? Or pre-STEM, so you can go to algebra for STEM for your major, right? You have to know how to solve equations. That's like foundation thing, so we need to work through that. So somebody see a mistake of mine?
Not a mistake, but so on the, when you're trying to do the fraction thing on number or letter F, so you multiply those two numbers on the bottom. So like I'm trying to get, I did a 30/1 and a 3/2. So like simplify them.
Yeah, you can put this over 1. And then I was cross reducing, 2 goes into itself 1 time and into 15 or 30, 15 times. And then you would multiply what's left over on the top. And then the bottom, we have 1.
I divided, so that's where.
That's probably it. Anyways, I just always say that because, you know, sometimes we're not algebra minded, but if your degree, I say minded, it's not our favorite thing. Let's say it like that. If your degree requires algebra for STEM, we have to know how to solve equations. Otherwise, we're not gonna put in the time and the effort to do that. If that's just not something you think you're gonna want to do in your life, you might want to rethink what math pathway, what degree you need, and maybe taking a different math. But all of you, I think you're on a really good start, so I'm proud of you. Good job. Remember that